Module 2, Lesson 10, the distributive property and the products of decimals. So once again, this is pretty much a review lesson. As we are going to be taking a look at multiplication of decimals, which was a 5th grade topic. And so just like in Lesson 9, we're going to try and look at it in a slightly different way and try and take our thinking a little bit deeper. So looking at our ICANN statements here, I can use place value and the distributive property to find the product of decimals. So we're not focused exclusively on the standard algorithm. I can justify the product using arrays and partial products, so showing what's actually happening, actually using models to demonstrate our understanding. All right, so opening activity here, just quickly doing things the standard way, the standard algorithm. So we've got 200 multiplied by 32 and 6/10. I really should quit trying to write everything on an angle. So I have multiplied the tenths place times the 200. And now I'll multiply the ones place times the 200. And now I will multiply the hundreds place times the 200. And I will combine it together. And I will look and say there is one decimal point. So I will have 6,520. All right, taking a look at the second one. I'm going to use the commutative property here and change the order of the factors. I don't know why, but my brain likes to have the number with more digits on the top. All right, multiplying the ones place, multiplying the tens place, and now multiplying the hundreds place. 5 times 2 is 10, regroup, 5 times 1 is 5, plus 1 is 6, 5 times 2 is 10, and I will regroup and get 11, and I will add things together. And I will move the decimal 2 places because there are 2 decimals, and I've got 11,060. Now, something I could have done before I started that we worked on yesterday was using estimation to quickly get an idea of what the product is, so then I can then look at my answer and ask whether or not it makes sense. So I could have this as 200 and this as 30, so 200 times 30. And if I were doing this mental, I'd do 2 times 3 and get 6, and I've got 3 zeros. So my answer is going to be somewhat close to 6,000. So I am in the ballpark. I have a reasonable estimate. For 500 times 22, I would probably do 500 by 25. And once again, in my head, I do 25 times 5 to get 125. And I've got the 2 zeros, and so my answer needs to be somewhere close to 12,500. And I'm, for the size of the numbers, reasonably close. I could also do 500 times 20 and get about 10,000. And once again, for the scale of the numbers, I'm relatively close. So we've looked at the standard algorithm, but today we want to look at partial products and distributive property. On this first example, going to look at the distributive property here. For the distributive property, we break numbers apart. So this 32 and 6/10 I could break into a 30 plus 2 plus 6/10. And the 200 needs to be multiplied by each of those. So I've got 200 times 30 plus 200 times 2 plus 200 times 6/10. And in case you've forgotten, when we use parentheses, that is a form of multiplication, so the 200 is multiplied by what is in the parentheses. So I have 200 times 30, and I would do 200 times 3 and get 600, and then I'd multiply by 10 more and get 6,000. And I've got 200 times 2, which is 400. And I would do 200 times 6 and get 1,200. And because this is 6/10, I would then divide by 10 and get 120. And now I can combine these together, and I have 6,400 plus 100 more, 6,500 with 20. Which should look really familiar because this is the same multiplication problem that we just did. So partial products and distributive properties. So partial products are I have got part of the problem that I am doing, and I've split this into 3 products. And the distributive property is also tied to the partial products. The 200 is going to be multiplied by the 3, multiplied by the 2, and multiplied by the 6. It is distributed. It is being multiplied by each of the parts of the other factor. Visually, we could set this up using a rectangular array or an area model, and it would work very similarly to what we just looked at. I'm going to break things apart. The 500 is nice right where it's at. It's easy to multiply by. I'm not going to do anything with it. But this 22 and 12/10, I could do some breaking apart here. And there are a lot of different ways I could break it apart. I could have 20, and I could have plus 2, and I could have plus 12/10. So I have taken this, 12/10, 12/100. So I have taken this 22 and 12/100 and I have broken it down into parts of the factor. And now I can treat it like an array. 500 times 20, which will give me 10,000, and 500 times 2, which will give me 1,000. And I've got 500, and I'm going to worry about this decimal here in a second. 500 times 12, which would give me 6,000. But this isn't a 12, this is 12/100ths. So I need to divide by 100. And 600 divided by 100, 6,000 divided by 100 gives me 60. And then I can combine these together, and I've got 11,060. So once again, looking at the partial products, I've taken one of the factors and I have broken it apart. And I have distributed then 500 times the 20, 500 times the 2, 500 times the 12/100ths. And additionally, I have represented this using an area model. Area models in math are frequently rectangles, length and width. All right, so there's going to be some exercises to complete. And for the exercises, you are using partial products to justify your answers, and you are going to record your work in the correct box. It says partial products. You don't have to use an area model, but if it helps you see what is happening in the problem, that's wonderful. I would also invite you to be thinking about the connection between partial products and the standard algorithm. The connection between these two approaches. We're both getting the same answer. If we use the standard algorithm, if we use the partial products, we're getting the same answer. But what is the same about them? What is the connection besides the same answer? All right, so I'm going to skip the stopwatch here. All right, so looking at partial products on station 1, we've got the product of 325 and 4/10. So I am going to break this into 300 multiplied by 25. It's easy to multiply by 25, so I'm going to do that. And then I've got 300 times 4/10. So I've got 25 times 300, 25 times 3, and really my mental math strategy is also a partial products, because I'll do 25 times 3, and then I will multiply times 100. So 25 times 3 is 75, and 75 times 100 is 7,500. And over here I've got 300, and I'm going to multiply it times 4 and get 1,200, and then I'm going to divide it by 10. I multiplied by 4, but the factor was actually 4/10, so I need to divide by 10, and I would get 120, and if I combine those together, I get 7,620. And this is obviously a representation using partial products, and I'm demonstrating some mental math strategies as I go through this. If I were to set this up in an area form, I would probably put 300 on the bottom here, and I would split, and I would have 25, and I would have the 4/10. So then I could multiply 300 times the 25, and I'd once again get 7,500. And 300 times the 4 is 1,200, and then I divide by 10 and get 120, and then I can add them together. I have seen some uses of the area model where they put the 300 on the top, and then they line up the place values within the area model so they can add down through the area model and get their sum as they combine these parts. Partial product. In the word partial, we have the word part. We are finding the products of parts, and then we are combining them together to make the complete product. All right, station 2, calculating the product of 45 and 9/10 times 100. So I'm going to split the 45 and 9/10 into 40 times 100, plus 5 times 100, plus 9/10 times 100. Now I know that there are faster ways, but I'm supposed to be using partial products to do this. So 40 times 100 is 4,000, and 5 times 100 is 500, and 9/10 times 100 is 90. So and 9/10 in my head is 9 dimes. If I have 9 dimes and I multiply it times 100, then I have 90. $90. Boy, that'd be kind of nice. Is that right? I better stop and think about this for a second. 9/10 times 100. Yep, 90. Okay. In my head, I just did 9/10 times 10, which would give me 9, and then I multiplied by 10 again, which got me 90. So just a quick explanation of my mental math there. All right, so I have my parts, my partial product, and now I can combine together to have 4,590. All right, taking a look at station 3, 800 times 12 and 3/10. So I could have the 800, and I could multiply it times 10, and 800 times the 2, and 800 times the 3/10. And 800 times 10 is 8,000. And 800 times 2 is 1,600. Just a quick explanation of my mental math process here. I do the 8 times the 10. Well, I do the 800 times 1, which would give me 800. And then I multiply that times 10, so 800 times 10. And that gives me 8,000, 10 800s. Here I do 8 times 2 and get 16, and then I multiply times 100, 16 hundreds. And here I'll do 800, well, 8 times 3, which will give me 24, and then I will multiply times the 100 to give me 24 hundreds, and then I'll divide by 10 because this isn't a 3, this is 3/10. And so as I divide by 10, I get 240. All right, so I've got 9,600 plus 240, and 600 plus 200 is 800, 9,800, and add 40 more, 9,840. All right, taking a look at station 4, I've got 400, and I'll set this one up with an area model. So I have the 400, and I've got the 21 and 8/10, and I'm going to split the 21 and 8/10. I'm going to make it into some parts here. A part of 20, a part of 1, and a part of 8/10. So, 400, not 40. All right, so I would take this mentally, and I would have 4 times 100, and I would do the 4 times 20, and I would get 80, and I'd multiply by 100, so I would have 80 hundreds, which is 8,000. And 400 times 1, well, that's just 400. And then I would take the 400, and I would have 4 times 100, and I would multiply the 4 times the 8 and get 32, and multiply the 100 of 32 hundreds. But then I would remember that this 8 was 8/10, so I would need to divide by 10, and I would get 320. And then I can combine the parts, find the sum of the parts, and I would get 8,720. All right, station 5 here. I should have been modeling, doing a little bit of estimation before I started. I've got about 30, and I've got about 200. 30 times 200, which will give me about 6,000. So estimating my answer, I'm going to be in the area of 6,000. All right, I've got 30 times 200 plus 2 times 200 plus 6/10 times 200. So the 32 and 6/10, I have broken it apart into 30 plus 2 plus 6/10. All right, 30 times 200 would give me 6,000. So 30 times 2 would give me 60, and I would have 60 hundreds because it's 200. 60 hundreds is 6,000. And 2 times 200, 2 times 2 is 4 hundreds. And 6 times 200 gives me 6 times 2 is 12 hundreds. But this isn't a 6, it's a 6/10, so then I need to divide by 10 and add 120. And so I've got 6,520. The 6,000, the 400 and the 100 make 520. 6,520. And I can quickly check and say, yes, that is in the ballpark. that is near my estimate. I have a reasonable answer. All right, so the challenge was, what connections do we see between the standard algorithm and the partial products? Well, if we go to station 1, we had 300, and we were multiplying it times 25 and 4/10. With partial products, I broke that into 300, and I multiplied it times the 20, and I added that to 300 multiplied by the 5, and I added that to 300 multiplied by the 4/10. In the standard algorithm, we would start by multiplying the 300 by the 4/10. 300 times the 4/10, and I was always saying I'm going to do 300 times 4, and I would get 1,200. We then multiplied the 5 by the 300, and we put a 0 in there because we've moved over one place value. So I've got 5 times 0, 5 times 0, and 5 times 3, which gives me 15. And 300 times 5 gives me 1,500. And then we would put 2 zeros because we've moved over 2 place value positions, and I've got 300 times 20, and I've got 2 times 0, and 2 times 0, and 3 times 2, which is 6. And I've got 300 times 20, which is 6,000. I then added these together, 6,000 plus 1,500, and this 120 here was this 1,200 was 1/10 because of the 4/10. So I have 120 that I am combining. If I look over here, I would move the decimal one place. So the decimal moves in, and I am now adding up the same 3 numbers. So the standard algorithm and partial products are connected because we're actually doing pretty much the same multiplication problems. We might be doing them in a slightly different order, and depending on how we break apart one of the factors, if I broke this apart to be 25, so if I did 300 times 25 plus 300 times 4/10, I would have actually combined these two parts into one multiplication problem, but here I'm still doing 300 multiplied by 25. So the connection here is that we're doing the same multiplication. We are multiplying everything in one of the factors by everything in the other factor. The 300 is being multiplied by all of the parts in the 25 and 4/10. The 300 is being multiplied by the 4/10. It is being multiplied by the 5. It is being multiplied by the 20. The form is different. We have kind of this vertical standard algorithm here. Here we have more of a horizontal partial products. But we are multiplying all the parts of 300 by all the parts of 25 and 4/10. And the opposite is also true. The 25 and 4/10, all of the parts of it are being multiplied by all the parts of the 300. So we're reaching the end of Module 2, Lesson 10. I can use place value and the distributive property to find the product of decimals. So place value, of course, is useful as we break apart the partial products. This is in the tens, this is in the ones, this is in the tenths. And place value is also important when using the standard algorithm. I can justify the product using arrays and partial products so I can show this is what is happening within the multiplication problem. I don't have to say, well, they just told me to do that. I can show and explain this is what's happening as I solve the problem. So this concludes Module 2, Lesson 10. If you've got questions, make sure you talk to your teacher and make sure you complete your problem set.